Today we're going to explore the graphs of sine and cosine functions. Here is the graph of sine of x. You can see, in fact, that it is periodic. The periodic nature of the sine graph shows that it actually goes on forever. This is actually a sine graph in Desmos. The blue outlines one period of the sine graph. You can see that the sine graph starts here at the midline and goes up to the maximum, which is at 1, goes back to the midline at pi, goes down to the minimum at 3 pi over 2, and then goes back to the midline at 2 pi. And this continues on. What you just witnessed was one full period. The cosine graph is very similar to the sine graph, except it starts and ends at a different location in its period. The cosine graph actually, for one period, starts at the maximum, goes down to the middle, and then goes down to the minimum, then back to the middle, and then back to the maximum. Every sine graph can actually be written as a cosine graph, and every cosine graph can be written as a sine graph. The only difference is they're shifted. They're shifted, as you can see, by pi over 2. This is where a sine graph starts, and this is where a cosine graph starts. This portion of the notes just details exactly the nature of the sine graph. You can see the sine graph starting in the middle, going up to the maximum, back to the middle, down to the minimum, and back to the middle. And the cosine graph, which starts at the maximum, goes to the middle, down to the minimum, back to the middle, and up to the maximum. Both of them have a period of 2 pi. As stated before, both sine and cosine functions are periodic. In other words, their graphs have a repeating pattern. The shortest repeating portion of the graph we call a cycle. The horizontal length of each cycle is called the period. So you can see here is the length of one cycle on a cosine graph, and it's 2 pi. The period for both sine and cosine graphs is 2 pi. Now, sine and cosine graphs have some symmetry that we've seen in the past. Sine is what's called an odd function, which we have talked about before, which means it has symmetry with respect to the origin. The cosine x is an even function, which means it has symmetry with respect to the y-axis. We talked about these ideas of symmetry at the very beginning of the year. There are 5 key points of both a sine and a cosine graph. The sine graph starts in the middle, goes up to the maximum, back to the middle, down to the minimum, and back to the middle. We call each of these tick marks, some people call them tick marks, I call them jumps. There's 4 of them in each periodic, each length of the period. For cosine, it starts at the maximum, goes down to the middle, goes down to the minimum, back to the middle, and up to the maximum. Every single trig function has the same set of characteristics. You have A, which is the amplitude, which affects the graph. You have B, which affects the period. This entire term affects the phase shift, left or right. And then D is our middle line. Today we're going to explore A, B, and D. And we'll talk about BX and C combined tomorrow. This is one period of a sine graph. You can see that the amplitude is the distance between the midline and the maximum. It's also the distance between the midline and the minimum. This distance right here is our amplitude. The middle line is the starting point of our sine graph, which is always represented by D. And then B affects the period. We'll talk more specifically about B. Bx minus c is the phase shift, but that involves a lot more work. Here is the cosine. Here is also the sine, sorry, but it just has some of the details. The middle, the max, middle, min, middle. We'll talk about this when we're graphing. There are some key things you have to keep in mind. The amplitude, which is A, is always found by doing the maximum minus the minimum divided by 2. In the equation, A, if this is 5 sine x, 5 would be our amplitude. The midline is, which is D, is the average of the maximum and minimum. So to find the midline, you take the maximum plus the minimum divided by 2, and that gives you D. Now the period and the B value, this is how they're related. So the period, T, we call it the period T. T equals 2 pi over B. So if you have B, you know B, you can find the period. So in a basic sine graph, B is 1, which is why the period's 2 pi. This talks about the shifting positions if a sine graph is negative or positive. We'll talk more about those in detail when we do an example. We're now going to look at some examples. The first example we're going to look at is the equation of y equals 5 sine x. So since there's a 5 in front of the sine x, that means our amplitude is 5, which means the sine graph 1, 2, 3, 4, 5. The maximum is going to be 5, and the minimum is going to be negative 5, because there's no other transformations with this sine graph. So now sine graph has a period of 2 pi when there's no b value. Okay, so b is 1, so the period is 2 pi over b. Now, with each period, we take the 2 pi and we break it up into our jumps. Our jumps are really our tick marks. So we take 2 pi and we divide it by 4. So we have pi over 2 represents each jump, which is really our tick mark. You can figure out what each tick mark is by taking pi over 2 and multiplying it by 1. That gives you the first one, which would be pi over 2. Pi over 2 times 2 is 2 pi over 2, which is just pi. 3 pi over 2 times 3, which is 3 pi over 2, which is just 3 pi over 2. And 4 times pi over 2 is 4 pi over 2, which is just 2 pi. These represent our tick marks. As you can see, I've taken our tick marks and put them on our boxes. Now, I decided that every box, instead of representing pi over 2, would be pi over 4, because that's half of pi over 2. And then our y scale would be 1. So since our jumps are every pi over 2, and it's a sine graph, I'm going to start in the middle, and then my first jump, which is pi over 2, is going to be my maximum. And since my amplitude is 5, I'm going to go up to pi over 2, comma 5. Then it's a sine graph, so I'm going to go back to the middle, and then I'm going to go down to the minimum, and then back to the middle. This is one period of sine. Now, if you go backwards with sine, if you want to go back, instead of going, you have to go minimum first. So we go minimum, middle, maximum, middle. There's another period of sine. So I've graphed 2 periods of a sine graph. Our second example is the equation y equals cosine of 4x. Now, since there's no number in front of the cosine, that's our amplitude, which means our amplitude is 1. Our b value is 4 because b is the number in front of the x. And then our d value is 1 because that's what's added. So because the d value is 1, that means that's our middle line. Before I do anything, I always graph the middle line first. Okay, since our middle line is 1 and we have 1, 2, 3, 4, 5 boxes, I'm going to make the y scale 0.5. And so our middle line is at 1, so we've dotted our middle line. And since our amplitude is 1, we need to go up 1. So our maximum is our middle line plus 1. In this case, it's 2. And our minimum is the middle line minus whatever the amplitude, in this case 1, is 0. So our middle line is 1, our maximum is 2, and our minimum is going to be 0. Now that we've taken into account the middle line and the amplitude, we need to deal with the period. Well, we know that t, which is our period, is 2 pi divided by the absolute value of b. Okay, in this case, b is positive, so it's 2 pi divided by b, which is 4, which means our period is pi over 2. So that pi over 2 represents the entire period. To figure out our jumps, we need to take our period, in this case pi over 2, and multiply it by 1/4. Now we could divide it by 4, but since it's a fraction, it's much more efficient to multiply it by 1/4. So when we take pi over 2 and multiply it by 1/4, we discover that our jumps are each pi over 8. In order to figure out each tick mark, we're going to take that pi over 8 and we're going to multiply it by 1, pi over 8 times 2, pi over 8 times 3, and pi over 8 times 4. To figure out our actual tick marks, we took pi over 8 and multiplied it by 1, 2, 3, and 4. When we simplified, we got pi over 8, 2 pi over 8, which becomes pi over 4, 3 pi over 8, which doesn't simplify, and then 4 pi over 8, which becomes pi over 2. You could keep doing this again to find the next, the farther along. But all we needed to know was that we're going to make our scale pi over 8. So now we're going to actually graph. It's a cosine graph, so cosine graph starts at the maximum. So remember, here's our maximum line, and then it goes to the middle, and then it goes down to the minimum, and then back to the middle, and then back to the maximum, middle, minimum, middle, maximum. So that represents one full period of cosine, and here's your second full period of cosine. You should get in the habit of trying to do 2 full periods every single time. Our third example is y equals -1/2 sine 2 pi over 3x. Now there's a couple of things you notice. It's a negative sign. So negative sign has slightly different properties. The amplitude is 1/2 and the b value is 2 pi over 3. Because the b value is 2 pi over 3, we've got to figure out our period. Well, we take 2 pi divided by 2 pi over 3. When we do this division, we end up with the 2 pi's canceling out, and we end up with the period being 3. So the period of this function is 3. You can take the period, which is 3, and figure out your jumps by dividing by 4. When you divide by 4, you discover that the jumps, or the tick marks, are 3/4 or 0.75, which I have created as my scale. And then I took 3/4 and multiplied by 1, 2, 3, and 4, and simplified, and ended up with my tick marks being 0.75, 1.5, 2.25, and 3. You should leave it as a fraction unless it terminates. In this case, it terminates, so a decimal is perfectly fine. We have taken our tick marks and put them on the graph, and because our amplitude was 1/2, we made our y-scale a quarter, and so we have done our maximum line at 0.5 and our minimum line at -0.5. And this is a negative sine graph. So a negative sine graph still starts at the middle like a regular sine graph, but regular sine graphs start and go up to the maximum first. A negative sine graph starts at the minimum. Starts at the middle, but then goes down to the minimum. So middle, minimum, middle, maximum, middle, minimum, middle, maximum, middle. So the only difference with a negative sine graph and a negative cosine graph is it goes in the opposite direction. So a sine graph starts in the middle and goes down. A cosine negative starts in the minimum and goes up. This very last graph puts everything together. So I am going to graph it and then talk through what I had just done. Now we're going to talk about the key features. Our amplitude was 8 and our middle line was -2. So in order to find the max and the min, we just had to take the middle line and add our amplitude, so our maximum is 6, and our minimum is the middle line minus the amplitude, which makes our minimum -10. To find the period, you take the b value, which is 8 pi, and period is 2 pi divided by 8 pi, which is 2/8 or 1/4. Now to find the jump, you take 1/4 and multiply it by 1/4, which is 1/16. And then you perform the same math you always do to get the tick marks. Now it's a negative cosine, so negative cosine starts at the minimum, goes to the middle, up to the maximum, back to the middle, down to the minimum. Now remember, our maximum line was at 6, and our minimum line was at -10, and our middle was at -2. Thanks a lot.